Okay, for the next part of this tutorial, we're going to look at the player and movement around inside this level. So I've turned this direction light back on because I could probably do a separate little extra part. So we talked about these parts that we're going to look at. I didn't talk about lighting or anything. We could probably do an extra little video on that to make things look really, really cool. Maybe I'll do that as we go. To do that, I'll have to pull in the post-processing package. So yeah, that's a piece of work in itself. Right, so let's get a player inside here. Okay, so I've created this empty game object. Just before we do the player, I created this empty game object which I'm going to call level. And then I'm hoping that ProBuilder won't go crazy if I just bang all of these parts into that level game object, right? So I want to call this room lower. I'll call this room upper. This is our first, I suppose, conduit or tunnel. Let's call these tunnels. And these here, we'll just call these tunnel extended, just for the sake of it, just so we can recognize what's going on. So extended. And this one here is tunnel extended as well. Extended. Cool. Right, so this is the test. So here's my level. I want to make this the entire game object that holds all of these parts. So I'll save this first, and then drag those into my level, and then we can collapse that down. So now my level sits at this position here. That was silly. You know what? I'm going to take those out. I'll undo that. I want to center that. 0, 0, 0. And yeah, so that's the starting point right there. I can't see my grid anymore. I don't know why that is. So let's put all those in there now. So there we go. So that's centered. And I can collapse that down, not worry about it anymore. Cool. Right, so the next part, let's create ourselves a player. So the player I'm going to make out of a capsule. Dead simple. The player is going to sit at position 0, 0, 0 for starters. So that's where that's sitting. The player is pretty big. It won't fit anywhere inside those tunnels at the moment. So I believe I was making everything 5 by 5. So I suppose if that is, if he's 1 meter across, that makes sense. Alright, so I'm going to scale him down. So 0.5, 0.5, and 0.5. Okay, so it gives him a lot more space to play with. Let's move him up to 1 on the y-axis. He's kind of off the ground there now. Let's have a look. Maybe that needs to be 0.5, so 0.5. And then we'll throw a rigid body component on the player so that when you hit play, it will start using physics. Oops, right. Okay, so that's the first thing we need to sort out. It's the first time I hit play, I forgot about that. So our player is sitting there, and our camera is way over here. So a top-down shooter, did I say first-person shooter earlier? A top-down shooter suggests that the camera is above the player, looking straight down. So we need to rotate our camera forwards 90 degrees. So on the x-axis, type in 90. And then because we are rotated forwards like that, well, it means that our y-axis, well, it's still pointing up in this case, but depending on the actual setup, your orientation and your center axis and everything, that will change, right? What I like to do when I'm making top-down shooters is to have the camera sitting, in space like this, which is great. But because it's oriented in a funny way, I'm moving on the x-axis right now. As you can see, it's snapping to 0.5 increments. But if you speak to the code, so if you're coding this to move around after the player and you start moving the z-axis, well, it's actually working fine there. It must be something to do with my settings. But what I like to do anyway just in case I want to angle the camera a certain way. So if I didn't want that to be 90, I want it to be slightly offset, like so. Then you might run into problems, especially with code. Right now I'm centering it's kind of a global transform on. If I set my local transform, well now Z is up and down. Even though I'm moving on the y-axis, but the actual Z transform, and here's the y-axis controller, is moving backwards and forwards. So we don't necessarily want that. So what I like to do is create an empty game object. I'm going to call that my camera holder. And this is the object that I'll put all of the scripting and translations on for my camera follow. Okay, so that's going to be a little extra script that I didn't mention before, a little bonus content. So camera holder is set to 0, 0, 0. My main camera, let's make that a child of my camera holder. I'll set its position to 0, 0, 0. So it's right snapped against that actual camera holder. And then if I move the camera holder up in the air on the y-axis, like so, and make sure that my camera is, yeah, there it is, it's facing straight down. So there's my camera holder, which I know is perfectly aligned to the world. So if I move it up on the y-axis, it will move up on the y-axis. If I move it on the z-axis, it will move forwards and backwards and all that kind of thing. So that's just a kind of a safety thing. It's nice. It means that I can actually rotate this slightly and do interesting things with it without having to worry about my orientation. Cool. So do you know what? That might be one that we could tackle now quickly. Let's create a scripts folder. So create folder scripts. And just before we start actually moving the player around with script, we'll just make a little script that forces our camera to follow our player smoothly. All right. So let's call this. Right-click in here, create a C# script. So sorry, right-click inside your scripts folder. So highlighted scripts. Right-click in this empty space and create a C# script called camera follow. And that's just drawn my attention to the fact that I have a very strange layout with Unity here. Okay, so I should probably mention that at some stage in the video. It's a bit late in now. The setup for this is basically I have taken, usually you would see something in a kind of a 2:3 aspect ratio, where 2:3, where you'd have your game at the bottom down here, your scene will be at the top, and then these extra menus are kind of split up. I like to have this laid out for when I'm dealing with Pro Builder, and more so and more now I'm actually starting to use this as my way of dealing with Unity in general, because I'm starting to use Pro Builder so much now. So yeah, I will try and put the instructions on how to set this up in a video and put that in an introduction or something. Okay, so we've created our camera follow script. Let's drag that onto our camera holder. All right, and then double click on your camera follow script and wait about 10 years for Visual Studio to open. Okay, that was not too bad. Alright, so what I want to do is I want this camera to follow my player at a certain height. So I don't want the camera to move exactly to the player's position. I want the camera to follow the X and Z position of my player while remaining at a certain height. So I'm going to make all of this publicly controllable. So public float camera height. I'll also put a distance, a public float camera distance. So this will be how far away it is from the player if we want to have kind of an increase on the z-axis. So if we're going to go slightly before or slightly after the player. What else do we need? We've got the height, camera distance. How fast do you want the actual camera to move to the player's location? So public float camera speed. And then you also need a reference to the player. So public game object, or player is a game object, player. And do you know what? Maybe not. Let's make this a little bit more modular so you can use it for other things as well, not just the player. So let's just say target. This is the target you're gonna follow. All right. So this is a simple enough script. We always want to adjust the position that we're targeting based on these details. Okay, so we need to inside not an update. Update will actually do the job, but not as well as fixed update. Fixed update will almost guarantee you that the camera will be drawn in the correct position based on time, as opposed to update, which will try and force the camera to always be where it's supposed to be. Fixed update is a nice way of procedurally moving objects so that they keep in time step with your frame rate or your renderer. Okay, so what we got to do is create a position. So vector3 target position is equal to let's say it's equal to a new vector3 made up of the player. Well, do you know what, we could do it differently. Let's say it's just equal to the player for starters. So player dot transform, not the player, sorry, the target. Confusing myself. Target dot transform dot position, and then we can adjust it. So its distance and its height need to be adjusted. So target position dot y plus equals camera height. So this is going to take the target position dot y, which is now equal to the target dot y, so our player's y position, and it's going to add to it the camera height. So it's plus equals basically means this is equal to itself plus this. So you could write it as target position dot y is equal to target position dot y plus camera height. Okay, these two lines do the exact same thing. This is just way neater, and it's better practice. Okay, so yeah, let's go with that. All right, so our target position dot y plus equals camera height, and then your target position dot z. Now, this is an interesting one. Is it plus equals or minus equals? Because if you're saying that you want the distance to be kind of drawn back, so if you think about it, thinking about z going forwards and backwards, if you want your distance to pull your camera further away, closer to you, then I would say it is minus equals. I might get this wrong. We'll have a look. Camera distance. And then you need to lerp. So we need to do a linear interpolation where we actually move the position of our camera to this new target position over a certain step. Okay. Now I'm not going to go into the actual details of how a lerp works. Just imagine that it's kind of moving your current position to a target position over a certain percentage of the remaining distance. That's the best way to think about it. So how do we do it? Well, let's take our transform dot position is equal to vector3 dot lerp from our current transform dot position, where we are. And by us, I'm talking about the camera itself. Transform dot position to our target position over camera speed multiplied by time dot delta time. So this is actually the time dot delta time, so that it keeps in step with the actual update cycle of the Unity engine. Okay, so Right, so we got these public variables, speed and all that kind of stuff, and we got this target. All of these are now empty, or at least these will be set to 0, which is not what we want. And we have an empty reference to our target. So let's fill those out and see how this works. Our camera holder has the script attached to it. So we need to drag the player, which is a capsule. Let's change the name of that to player. We need to drag that into our camera holder. So that goes into the target. The camera height, well, what's it set at currently? It's 2.5. Let's say that's equal to 1, just for, well, a little bit higher. Oh, that's interesting. Its position, put a 2 in there. Yeah. Is that still not working? This happens from time to time now lately. I'm not sure what it is. Is it the fact that I have something selected down here? Is it this? I don't know. I can't actually increase this. I don't know why. It's like something I pressed, but anyway. Oh, it's because I've got the grids. It's the grids, isn't it? Yeah, that's all it was. Okay. Right. So let's say that we had this random number here. Let's put our camera height in at 3. The distance we'll put in as 1. And the speed that we move at, right, this is an interesting one. Let's just put a 1 in there and see if that works. We might need to make that a smaller number. Alright, so if I hit play now, there you see your camera will adjust itself slowly to hit that position. And as we actually, if I increase that height, you can see that it actually smoothly moves to try and target that position. Okay, and the distance is, let's move it to about, I suppose, there's kind of cool. So now, as I move the player around, so if I go back to my scene mode, and if I drag this guy around, you'll see the camera is doing its best. Ooh, right. So my player, I need to deal with his rigid body. So let's go into that now. So anyway, that's the camera smoothly moving around. So let's get into the actual controls of our player now, so we can see that in action. Let's see, let's stitch together properly. Cool. So the control system, right? So we're using a rigid body, and this is not a very typical control system. It's very, very basic. I'm probably breaking all the rules, but I just want to show you how you can actually communicate with the rigid body and how you can move the character around using forces or velocity. And that's before we actually move into raycasting and rotations. So we actually change the orientation of our character. So what we don't want our player to ever do is to fall over, just like it was when I was hitting play there. So the first thing we're going to do is go into our rigid body, go to our constraints, and say that we don't need to jump because it's all a flat surface. So let's hit a Y there. So we freeze the position on the Y. We want to move on the X and the Z. And on the rotation, we never want to roll to the left or right or X on the X axis, nor do we want to roll forwards or backwards on the Z. Okay, so we don't want to roll forwards this way or roll this way or this way. Rotation is important, so we do want to be able to rotate. We're going to use rotation to orient our character. Now, I might switch that off. Something's just popped into my head where sometimes you can actually bump into things and your character starts spinning with inertia. So it has this force applied to it where it's using the rigid body, where it's kind of basically rubbed its shoulder against the wall and it starts spinning. So let's leave that there on for now, and if we start getting that mad spinning stuff, we'll fix it up later. Okay, so that means that our character shouldn't fall over anymore. So now if I hit play and go to my scene mode, you can see our camera's updating nicely, and look, yeah, we don't actually fall down. So that's pretty cool. Alright, next part, we need to actually create our camera, or our player control script. So I'm going to create another C# script, and let's call this player movement. I like to give my scripts quite specific names. They just basically whatever they're intended to do, or whatever the intended use is. There's no point in trying to create a script that does all of the things. It's nice to keep things modular and specific when you're learning to program. So let's drag the player movement script onto our player, and then let's start moving things around. So that rigid body is going to be how we physically drive this character to move around. So in my player movement, I'm going to create a reference to that rigid body. So rigid body, body. Then I'm going to say what the body is, because right now that's just an empty reference. Body is equal to get component. This reaches into the component stack on your game object and finds the first instance of a rigid body that it can find, and then applies it to this. So it assigns the rigid body to here. So in effect, what happens is this rigid body component right here gets assigned to this body right here. Okay? So from this point onwards, after we start, sorry, I should have mentioned that the start function happens whenever we hit the play button. After we start, this body then refers to this component right here. And it's this that's responsible for making things fall over, bumping into things, rolling around the place. And that's why we had to actually put those constraints on so that things wouldn't actually, the player wouldn't roll around or fall when we apply physics. Okay. So what do we want to do? Well, we want to say that when we press certain keys that the body moves in a certain direction. For that to work, we need to create our own velocity, right? So once again, this is not your typical or standard or widely used script for moving things around. It's just an introduction to get you familiar with how rigid bodies work. I'm going to create a velocity and override the velocity, which is speed in a given direction. I'm going to override it with our own velocity vector. So I'm going to create a vector 3 velocity, or let's call it our velocity. And we're going to say that's equal to body dot velocity. Right, there's my first mistake. I'm going to say that is not equal to the body velocity. I'm going to say it's equal to vector 3 dot 0. Is that correct? I think so, yes. Now, the reason why I'm doing this is I want to constantly say, no, you're not moving anywhere. So let's make vector 3 0, or our velocity equal basically 0. It's saying that it's moving 0 on the x-axis, 0 on the y, and 0 on the z. Okay. A vector 3 is simply a structure that holds an x, y, and z coordinate, just like in here where we've got our position, rotation, and scale. Each of these are vector 3s. They've got an x, y, and z coordinate inside them, amongst other things. We used a vector 3 in here to linearly interpolate between this position and this position. So there's other functions and stuff attached in here. So don't freak out if you don't understand this language. Some of you are thinking, yeah, get on with it. And some of you are thinking, oh my God, what are these words, what they mean? Don't worry about it. You'll become accustomed with practice. Okay. What's more important than syntax and learning off these words is actually knowing how to do things, or even how to start thinking about doing things. It's one thing to be able to speak a language, but actually having something to say in the first place is more important, in my opinion. So our velocity is equal to vector 3 dot 0, meaning that we are now stopped until we do something. Let's say if input dot get key. So if I'm holding a key, what key? Key code dot w. So if I'm holding the W key, I want to do something. I want to apply something to our velocity. So what we got to do is we got to make sure, because we need to build this in a way that our player is going to move forwards in the player's forwards direction. So right now its forward direction is this blue arrow on the Z axis right here. But if we rotate our player that way is now forwards. Okay, so we can't just say move this direction, which is kind of up or forwards. I want to move relative to where our player is moving. Some people hate that about top-down shooters. In this particular control set, some people like to go up, left, right, and down, and then click and shoot at different positions with the mouse. I like to set up this control because I think it's more usable for when you want to branch out into maybe creating your own first-person controller or even third-person controllers. Okay, so let's look at that again. So if I'm holding the W key, I want to say that our velocity plus equals transform dot forward multiplied by, let's say, 1 for starters. So let's see how that works. If I hit play, let's wait for the script to compile, and there we go. And if I hit the W key, absolutely nothing is happening. What's going on here? I've forgotten. Oh yes, I've forgotten something. Key. Thank God. So I've said that our velocity is equal to this, but I haven't said, well, what we do with our velocity. Well, right at the end of our update, we need to say body dot velocity is equal to our velocity. Okay, so let's try that out. Alright, so if I hit W, off he goes. There we go, and then we hit the wall, and then I can't go anywhere else. Also, my camera, it's following at too great a distance. I think this should be far less. Maybe there's good. I don't want to be directly on top. I'm just going to have this slightly offset, so 0.35. I'm going to copy that and hit play, and now I'm going to have to input it again, because if you make any changes while playing, they won't be recorded. So I'll put that back in. And yeah, let's look at that again. So if I hit W, the character can just walk forwards, which is great. And then I can hit the wall. Cool. And also the speed at which our camera is following needs to be adjusted as well, so we'll deal with that in a little while. Alright. So let's look at moving backwards. Well, if we just copy all this code, put it in here, and if I put, instead of a W, I put an S. So W, A, S, and D are the controls. S for backwards. I want to say our velocity plus equals transform dot forward multiplied by -1. So this negates it. In Unity, our transforms have a forward, up, and right variable that describes the forward, up, and right directions. It doesn't have the others. So basically, to get backwards, you just multiply forward by -1. To get left, you multiply right by -1. And to get down, you multiply up by -1. So this should work as well. Play again. So I got forwards, and now I got backwards. Our character stops as soon as I let go. And that's because we're saying their velocity is equal to vector 3.0. Now, all we got to do is copy these two and modify them slightly so that we can go left and right. So input get key code D for right, which is transform dot right multiplied by 1, and for A, which is left, we just say transform dot right multiplied by -1. And the beauty of this is it's actually adding each of those changes as we go. So it's saying if I'm pressing keys. So now if I hold key combinations, I can go on diagonals as well. So I'm hitting down. Ooh, that's interesting. It seemed to have rotated slightly. Am I rotating? That is strange. What is happening there? So W is forwards. So if I click on player, yeah, as you can see here, like the players hit something and they're rotating out of control, right? And that's what I was talking about earlier. So now if I hit W, they're kind of spinning and turning at the same time, which is good in that it means that when I hit W, which is forward, the character is traveling forwards. It's bad because it's going to mess with our control system. So what I'm going to do is on my rigid body, I'm going to hit that freeze rotation on the y-axis again to stop that happening. It'll stop those physical impulses making the character turn. So I'm hoping that when I go to do my next part, where I try and rotate the character to look at the mouse position. That won't have an impact. But we can always fix that by turning it off, and hopefully just by looking at that mouse position it will fix it. So just one last point about that. These multiply by 1 and multiply by 1 minus 1 values, I put those in there simply because what you can do now is create a public variable called speed. So public float speed, and then we could replace all those numbers with just that speed value. So we got plus speed and minus speed, and that will do the same thing. So if your speed is whatever, that will replace these values in here, which is kind of cool. And that's all you got to do for the movement part of your script. Sorry, I'm going to check one more time. Here's our script. Let's put in a 1 in there, just like it was. You can make that 1.1 or 1.2 or whatever floats your boat. There we go. So backwards, forwards, left, right, and no collisions, which is really great. Okay, no. I wonder if we can actually still go through here. Ooh, we can. Look at this. That's kind of cool. One of the things I love about Pro Builder is straight away it puts collisions on everything for you. So even though I'm hitting against these walls and stuff, I'm not actually falling through them. That's kind of interesting. That wall is a little bit jarring there. I'm not sure if I like that, but look, it's a prototype, guys. There we go. Alright, cool. So in the next section, we're actually going to turn our character to face wherever the mouse is looking. So if I look over here and I hit W forwards, the character will actually walk in this direction as opposed to going up and down.